My name is Kim Hitsong from the University Advancement Division here at St. Lawrence, and I will be helping to moderate tonight's lecture. We're very excited to offer this lecture series here at St. Lawrence as a way for our alumni, parents, and friends to experience today's classroom firsthand. Tonight's lecture is our 11th in the series, and we're looking forward to many more to come. Before we get started, I'd like to cover just a few technical details that should help make your webinar experience a more enjoyable one. We will pause throughout the lecture to invite your comments and questions, and at that time you can virtually raise your hand using the hand icon that you should see in the navigation pane at the top right of your screen. The icon is a small hand in blue or yellow towards the bottom of that bar. You click it once to raise your hand, and when you're called on, you'll have the opportunity to ask your question directly. If you prefer, you can also type in a question or comment. Just a few tips about the webinar audio. If you happen to be using the audio through your computer, just know that you have to have a built-in microphone or an external microphone in order to ask questions. Otherwise, we'll be able to hear you, or you'll be able to hear us, excuse me, but we won't be able to hear you. If you're using your telephone audio and you have your phone on speaker during the lecture, in order for us to hear your question, you'll likely just need to take the speaker off during that time. We recommend that during the presentation you minimize the navigation pane by using the orange arrow near the top. And if you need to maximize the pane at any point to ask a question or make a comment, simply use the orange arrow to maximize it. So without further delay, I'm pleased to introduce our lecturer for the evening, Erica Barthelmess, Associate Professor of Biology. Erica is a vertebrate ecologist and conservation biologist. She earned her BA in biology at Earlham College, where she spent a semester abroad in Kenya. She earned a PhD in systematics and ecology at the University of Kansas and conducted postdoctoral research at Vanderbilt University before arriving at St. Lawrence. She is currently serving as co-chair of our biology department and is the faculty coordinator for the conservation biology major. She is also the project director for Nature Up North, an initiative that you'll learn more about a little later in the lecture. So we're excited to welcome Erica tonight, and our lecture is entitled Science by the People, Science for the People, the Rise of Citizen Science. So welcome to Erica.
Thank you. Good evening, everyone. I'm going to try not to shout at you because I'm used to lecturing to rooms full of people, and Kim is actually the only person physically in the room with her. So thank you very much for coming. And let's take it away. So some of you I know very well, I can see from the attendance list, and you will recognize which one of the people in this picture is me. But to assist those of you who don't know me, that's me in the St. Lawrence hat. This picture is with a group of my mammalogy students from this semester and a porcupine, in case you can't recognize what that furry thing is. So as Kim said, I'm a vertebrate ecologist. I'm surprised after that nice introduction that I have time to do anything, much less give a talk this evening. But I'm really happy to be here and share with you some things that we've been working on here at St. Lawrence. Before I get started, I like to do thanks at the beginning. And first I want to thank Jacob Malcolm, who is currently the Nature Up North project manager. You'll hear, as Kim said, more about Nature Up North. But not only do I thank Jake for his help, he also made some of the slides that you're going to see in this talk, so he deserves credit for that. I want to thank Kim for inviting me because it's really a fun opportunity to get to reach out to some far and wide Laurentians. And thank you all for showing up this evening. The plan for the talk is to spend a few minutes looking at sort of the post-World War II history of how people relate to science in the United States. That will be the depressing part of the talk. Then move on and talk about citizen science as one of what I hope are many antidotes to the problem, and close by focusing on some citizen science work that we're doing at St. Lawrence. If you have any questions along the way, I'm going to stop at each of the three sections, at the end of each of the three sections for questions. But if you want to send anything in, Kim's the miracle worker on the technology side. Okay. So I'm citing here a book as we think about the brief history of our relationship to science, which is at the bottom of the screen, Unscientific America, How Scientific Illiteracy Threatens Our Future. This is a really easy read, and if you're interested in general in scientific literacy and science communication, I highly recommend it. Some of the information I'm going to be talking about here comes from this book. So first, if we think about Americans' perception of science at the end of World War II, the dominant view was scientists as heroes. And if you think about it, it makes sense given that we had some important technological developments that probably helped us win the war. One being radar, which is of course developed from understanding how dolphins and bats use echolocation to navigate their environments. Of course, also the development of the atomic bomb. And so physicists in particular were seen as the people who saved the free world, and science was really heralded as a pretty wonderful discipline to be in. Yeah. As we moved out of the war into almost the early 1970s, the nation was really on a scientific mission. And so FDR, President Roosevelt, employed a guy named Vannevar Bush, who at the time was the director of the Carnegie Museum of Science, to work on a report that was called Science, the Endless Frontier. So it was a report that was commissioned by FDR to look at what we might do with science in the future coming out of the war. And so I thought this quote, these two quotes were pretty interesting of Bush's. The first is, "The pioneer spirit is still vigorous within this nation." And the second, "Science offers a largely unexplored hinterland for the pioneer who has the tools for the task." So you get the sense from both of these quotes and the fact that FDR was commissioning people to sort of explore how we could view science as our next frontier, as really a nationwide appreciation for and interest in investing in science as an undertaking. And that was evidenced in a variety of ways. So between 1953 and 1961, there was a dramatic increase, 14% in federal funding for science. And between 1940 and 1963, the research and development budget went from $74 million to $12.2 billion. So that's a really dramatic increase in a matter of 20 years. During that same time period, we saw the creation of NASA and the National Science Foundation. So really a lot going on. And yet, as the 70s emerged, we've seen ourselves entering a new light. And so now I've flashed forward to today and thinking about where Americans are at in our appreciation for science. And this is a screenshot from earlier today from a website called Science News. And I highlighted this one article. "Patients don't understand risks of unnecessary antibiotics," the study shows. And so the point I'd like to make here is just that as we have moved, perhaps you could think of it, into a much more technological age with the rise of the internet and smartphones and iPads and technology everywhere. At the same time, we've developed a decreased scientific literacy in the country. And it matters not just that physicists can develop nuclear warheads, but it also matters in our everyday lives. If you don't understand antibiotic use, that's going to have repercussions for you as an individual and for us as a society. In another example, you are maybe aware of the way in which people have been responding to the use of vaccinations. This is an American phenomenon for the most part. There are other parts of the world that fear vaccines, but not because of the medicine they provide, more for political reasons, and I'm thinking about trying to eradicate polio in the Middle East. But in the United States, we have developed a fear of vaccines because of celebrities who link their association to autism, even though there are no scientific data that credibly support that. And yet, when celebrities go online and talk about their fear of vaccines, rather than having a scientifically literate society that says, "Oh, well, that's silly," we end up in a situation where we're seeing increases in illnesses that we thought we'd stamped out, like whooping cough, for example. And the third instance has to do, of course, with climate change. I don't know all of you in the audience, and we may have different views about different aspects of science, but the scientific community is overwhelmingly supportive of the view that not only is the Earth's climate changing, but that the climate change is caused by human activity. And yet I like this cartoon because what it sort of focuses on is the skeptics picking out just these tiny little issues that really don't have anything to say about the big picture. And what happens is, for a variety of reasons that we can discuss, if you have questions or comments about them, we launch ourselves in a direction that's away from the main message instead of focusing on what the science has to tell us and what we might do about it. So why has this all come about? Well, in part, as I was saying, up through the 60s, there was a lot of federal research dollars being allocated towards science. And one of the changes that's happened has been in how those funds are allocated. And so this graph, which comes from the American Advancement, or the American Association for the Advancement of Science, excuse me, AAAS, this is a figure illustrating, since 1953, how much non-defense research and development money has spent by the federal government. And there's a couple interesting things, I think, that are worthy of note here. And just to orient everyone, the y-axis is looking at billions of dollars, okay? And they're measured in 2014 dollars. So it's taken into account change in the value of the dollar over time. And so one of the things that's really apparent is we've dramatically increased the amount of money we spend on research and health. And that's a good thing. You also notice that in the early 60s, there was quite a bit more money being spent on space exploration. And of course, with the Russians launching Sputnik in the late 50s, there was a real push to get people on the moon. But you see that that spending has held pretty flat, declined, and then held pretty flat through the 80s and up until today. The energy spending, energy research and development is what you see there in green, and you also see in the mid-70s a big peak there that then declines. And when you think about it, you know, energy is one of these things we hear about every day when we go to the gas station, and right now we're hearing all about how cheap oil is. But we really aren't spending any money. Here's what this graph shows us on research in energy, whether it's alternative or traditional forms of energy. For me, as an ecologist, perhaps the most depressing aspect of this graph is the light blue color, which indicates how much we allocate toward natural resource and environmental research, and you can see it's just a smidgen. And general science sort of captures everything else, again, not including defense monies. So on the one hand, when you look at this graph, you say, well, this is good because the total amount of money that we're spending towards research as a nation seems to be increasing. But if you compare that in the next slide with the funding as a percent of our GDP, so relative to how much money we have, how much are we spending, you see that basically since the mid-70s there's been a steady decline. And you also see that for every dollar we spend doing non-defense oriented research, we're spending quite a bit more money on the science of defending ourselves. So the point that I wish to make through all of this is if we follow the history from World War II to the present, we went from an era where research was really viewed in a very positive light by the American public to a point of rapid exploration and the space race, to a declining interest and declining funding in our overall science efforts. Coupled with that, and as I said, this is the depressing part of the talk, there's a number of sobering statistics that have to do with scientific literacy in the United States. So one of the things we note is that scientific literacy, and you might be asking yourself, well, how do you measure that? And we could debate about that. It is tricky. But in general, according to whichever way you measure, it's been stagnant 5 to 10% of the population, and that means that really only 5 to 10 out of 100 people that you would see on the street, for example, would be what we consider scientifically literate. Likewise, if you look at grade 12 high school students as they're graduating, only 18% have achieved a proficiency level that's required to be what is considered minimally scientifically literate. And to get back to the question or the slides I showed earlier about vaccines and antibiotic use, you know, this all matters because it impacts how we make decisions as a society and what we decide to value as a society. And when the average American's understanding of scientific concepts isn't adequate for making scientific decisions, right, it's not just those individuals who stand to suffer from the result. It's really the communities and the nation as a whole that stand to suffer. So that's the depressing part. I'd like to open it up for a minute to questions. So if anybody has anything you'd like to share with us or ask, we'd take a minute for that.
Okay, I am just going to take a look through the list of attendees. Again, if you have a question or comment, you can either raise your hand or type in your question or comment, and we'll get to those as well. It looks like we may have, oh, that hand just went down.
Well, how about this, Kim? We can warm people up by asking the poll questions.
Okay.
I forgot to do this. We were going to do this at the beginning, and I forgot.
Sure.
So we'll do a poll.
We can do that. All right. So we'll start with this first poll, which is just, did you want to introduce it or just?
Yeah, sure. This just helps me get a sense of who the audience is and helps you all get a sense of who one another are who are participating. And we didn't put, I think, the combined possibilities there, so you have to pick one. But understandably, you might fall into more than one of those groups.
Okay, we've got about 73% who voted. We'll just give it a second or two more for people to respond, and then we'll close the poll, and you should be able to see the results on your screen. Okay, we'll go ahead and close the poll. It looks like we've got the majority of folks who are alumni, 74%, 26% parents, and 4% who are friends.
Great. And let's go ahead and do the next poll question. In this one, we're just curious to know, in what discipline was your college major? And I apologize in advance, as somebody who is very much a liberal arts person in my heart, I don't like to have to pigeonhole you in these groups. So.
Okay, we've got about 76% of you voting. We'll just give it a second or two more and close the poll. Okay, great. So with that one, we have 56% of tonight's participants are from the sciences, 24% humanities, tied with the social sciences. We've got 8% with a fine arts major, and then 4% who chose other.
Great. And let's do the last one.
Okay.
Since we're about to start talking about citizen science, I thought it would be fun to find out how many of you have participated in a citizen science project before.
We've got about 80% of you who voted. We'll give it just a second or two. Get your poll in. Okay, we're going to go ahead and close the poll and share it. So it looks like about 52% of you said no, 28% said yes, and 20% weren't sure.
And I'm particularly happy for the folks who aren't sure. Hopefully by the end of today, you'll know the answer to that, although, well, we'll hope.
Great.
Yeah, let's just check. Did anybody have questions at this point?
It looks like no. It looks like Gordon Gannon actually may have a question. So Gordon, if you'd like to go ahead and ask your question or make a comment.
It's more a question. I was curious as to when you talked about the increase in the spending from 72 million to 1.2, if I remember the numbers correctly.
Yeah, 70,
what do you think the principal motivation was for that? It would not seem to be necessarily love of science, but perhaps a hatred of communism.
Yeah, I'm sure you're right that the Cold War plays a big role there, and the space race and dealing with the Russians. Speaking, of course, as a scientist and not a social scientist, that's my very wiggly answer. But I agree with you. I think that probably had a large role. At the same time, it's interesting to think about the fact that these were not all defense dollars. Not all of that increase went up in terms of defense spending, but just in research and development in general. So I don't think it's strictly relatable to the Cold War.
All right, great. It looks like that may be our only question right now.
Okay, great. Thank you for the question. So moving along, in the next section of the talk, I'd really like to address the question of what is citizen science, and there's many ways you could answer that question, but for a quick answer, I'm going to refer to the Cornell Lab of Ornithology. I don't know if any of you are bird enthusiasts out there, but Cornell Lab of O, as it's familiarly known, is one of the leading producers of citizen science in the world and has a long history of doing that. And they define citizen science projects as those in which volunteers partner with scientists to answer real-world questions. So we'll explore this idea a little bit further through some examples. But if you imagine a scenario where this might be you sitting at your computer anywhere in the world, so maybe you're in Canton, New York, or you're in Phoenix, Arizona, or you're in Nairobi, Kenya, and well, I'm actually strike Nairobi, Kenya. You'll understand why when I show you the next picture. But there you are, sitting at your desk, and probably not all of us have quite as fancy a computer desk as that. But you could, from the comfort of your desk, drinking your cappuccino, have the next experience. And that would be to go on safari, again, from the comfort of your own home. And the way you might do this is to participate in a citizen science project. So this example, called Snapshot Serengeti, is an instance in which the Serengeti, for those of you who may not be aware, is a very large savanna grassland system that spreads between southern Kenya and northern Tanzania. And it's the last home of one of the world's most significant mammal migrations. And what the scientists have done in this instance is they've placed out hundreds of game cameras. So these are cameras that you place out into the field, and an animal walks by, and the camera takes the animal's picture. I use these in my class with students. In fact, the Nature Up North project you're going to be hearing about in a minute is currently running a game camera contest in the North Country. So you can get these for a couple $100 and really have fun with them. But you might imagine if you have hundreds of these placed out all across the Serengeti, that the time it would take you to go through all of those pictures would really be incredible, and might overwhelm your ability to actually make meaningful information out of the data that you've collected. And so in this particular instance of citizen-based science, what they've done is crowdsource the identification of the animals in the pictures via this citizen science project. And so once you have logged in, what happens here as I drive through the, this example, you can see in the lower left there's the option to flick through the number of, there's usually 3 or 4 pictures that are taken at the same time. And then there's a guide here to help us figure out what this is. Boy, and this one's a little tricky. I think these are wildebeest, but they're clearly standing right in front of the camera. But basically what you can do is you come over here. There is a training module that you go through before you're trained how to do this in case you're not familiar with these wildlife. And it helps you identify, oh, well, I think it kind of looks like an antelope. And in this case, I think they look like wildebeest. And then it shows you a picture to confirm, although it's a little hard in comparison to our picture. And then it asks you to say how many. So I see 1, 2, 3. I'm going to say there's 3 animals there. And if I compare through this, click through the pictures, I get the sense from the pictures that they might be moving. And because I'm a behavioral ecologist by training, I would say they're interacting just by virtue of being so close to one another. And I don't see any young, so I say, okay, identify. And then I say finish, and it takes me to the next picture. And so you could do this, as you can imagine, and especially, for instance, if I have a lot of grading to do, this becomes much more interesting. So in this case, we've got some wildebeest that looks like in a Cape buffalo. So I can just come over here and say I see 1, 2, 3 wildebeest. And they also seem to be moving, and I identify them. And I say, oh, I think that's a buffalo. And I say, well, there's one there, and he is standing. And I say identify. Right? So one of the real wonders of this project, and in fact this particular example, Snapshot Serengeti, has had such a popular response over the internet that they basically just have it up here now for fun. They've analyzed all of their pictures. And you might say, okay, well, Erica wasn't paying attention. She didn't do a very good job analyzing this because she's giving a lecture at the same time. So the data quality are not going to be very high. But when thousands of people have looked at the same pictures that I've looked at, not only do you get the identification, but you also can get a sense of, for instance, I see a bunch of wildebeest in the back here that I didn't classify. You get a sense of the confidence around the identification. And again, this is all being done by the person who's just sitting in his desk chair at home. So here's our first example of citizen science. Citizen science is also sometimes called public participation in scientific research, and that's maybe a more politically correct term just to address the fact that not everyone who participates may be a citizen of the country in which they're working. It's sometimes also called community science or crowdsourced science, amateur science, volunteer monitoring. You'll hear it by all of these different names, but the basic idea is that scientists team up with the public, and depending on the project, the public has more or less knowledge or training in the particular area to collect data in a group effort. And sometimes it's online, like the example I just gave you, but it might be volunteer monitoring where people in communities sign up to go look for and pull out invasive plants in their neighborhood or something like that. So it can also be very hands-on. I suggested at the beginning of the talk that citizen science might actually serve as at least one possible antidote to the problem we face with scientific illiteracy in the United States right now. And the reason I think that is because of a number of features about citizen science. It works because you're crowdsourcing. Technology has advanced to a degree that, for example, in the Snapshot Serengeti project, you've got potentially an audience of hundreds of thousands, if not millions of people who are actually going to participate. Even if your participants are only groups of hundreds, you still have strength in numbers in comparison to one scientist. I'm thinking particularly of field biology and earth sciences because that's the kind of scientist I am, where collecting field data can be really time-consuming. Another reason that citizen science has a real advantage in engaging the public is that it reopens the scientific process and demystifies our sense of what science is. I'm thinking of some of you who reported that you were humanities or social science majors or fine arts majors. My brother is an artist and my sister a musician. They think I'm a little bit cuckoo. But I know, for example, that my sister's college experience was very much that I'm not good at science. She maintains a lot of science phobia, that this isn't something accessible to her. And when people come in with these preconceived stereotypes about themselves, the opportunity to participate in a citizen science project, especially if the project involves helping people see themselves as participating in the process of doing science, can really demystify the whole thing. So we move away from the stereotype of the scientist as crazy lunatic in a lab coat and more towards the model of scientist as every person. I want to give a shout out to a St. Lawrence alum, David Wald, who made me aware of this project as another example of a citizen science project. And so this is Did You Feel It? David is a seismologist for the USGS as well as a Laurentian from the class of '84, and this is a project that he works with in which basically what they do is crowdsource information about people's perceptions of earthquakes. And so what happens is if there's an event, and let me scroll down here and see if we can find one where people have actually reported in terms of recent events. In this case, an earthquake in northern Texas. And what we see in this instance has to do with the responses. They're colored by zip code, and the color corresponds to how strong the seismic actions were that the people felt. So in this particular example that I'm giving you, this was a very small earthquake, 2.6 on the Richter scale. And in North Texas, it makes me wonder if it's a fracking-related one. But here's another instance where there was an earthquake at the Virginia-North Carolina border, a 3 on the Richter scale. And again, getting a sense from people's perceptions of the quake, you can start getting a sense of how active these seismic events are and how far they can be perceived by the community. Get back here. So that's another really nice example of a way that citizens can participate. You're probably going to be interested if you feel an earthquake, so there's a high likelihood of engagement. You don't really have to know a lot of science in order to participate, and in this particular project, it's the crowdsourcing of experiences by many that helps the scientists put together better information about earthquakes. So some of the things that citizen science projects can do are improve scientific literacy. And again, I noted before that with fewer than 10% of American adults able to pass a basic scientific literacy test, anything that improves scientific literacy should be welcome. Citizen science projects also allow us to respond to community needs. And so, for example, I already mentioned invasive species monitoring, but many citizen science projects actually emerge from the communities in which people live, where a problem is noted, and the community will go to a scientist and say, hey, can you help us figure this out? In those cases, you often have a really high level of engagement. And then, of course, one of the other advantages of citizen science is it leads to lifelong learning for participants. So again, maybe you don't major in science, but you are engaged. We hope, and you all are examples of this. Here you are listening to a lecture right before the holidays. People who are interested in engaging in lifelong learning, which is really at the heart of what we hope for in a liberal arts education. Here's the first example that I know of citizen science. There's probably other examples. I could imagine the ancient Greeks doing some sort of citizen science. But what I know of is the first example is the Audubon Society's Christmas bird count, which in fact is starting right about now. It's an annual event that's been ongoing since 1900. In 2012-13, there were 71,531 observers. You might not be aware of this, but in the United States, bird watching is the #1 hobby. And so in this instance, and you can see from the globe, all of those yellow pins represent locations where people made observations. And so what happens is people are assigned particular locations that they're going to go out and bird in December. So you're looking at resident birds in your area. For us here in the North Country, it might be chickadees or cardinals or waxwings. In other parts of the world, of course, it's going to be other species of birds. But it's not during the migratory season, and you're getting a sense of what birds are present in what numbers at those times. This is an example of a citizen science project that emerged from the fact that citizens were already interested in collecting these data. And the folks at Audubon, now in association with the folks at the Cornell Lab of Ornithology, figured out as technology improved that you could actually get people to log these observations digitally and basically crowdsource information about the distribution, the worldwide distribution of birds. And so I want to make clear that in many citizen science projects, we're not just talking about citizen science as an educational tool that helps participants become more familiar with science, but we're also talking about situations like in the Christmas bird count where the participants are producing science that's leading to new discoveries. So for example, as a result of the Christmas bird count, we have a lot of new information about range shifts in birds, population declines or increases in different places, and potentially effects of a changing climate, basically because of crowdsourcing. And imagine how many professional ornithologists we would have folks just do this on the backs of scientists alone. So again, coming from the Lab of Ornithology, citizen science, like other types of science, happens when it produces reliable new knowledge. So one of the hallmarks of doing science is generating new information about how our world works. And there's no reason to exclude average, everyday folk from being able to participate in that kind of a process. Another really fun aspect of citizen science is that there's really something for everyone. So one of my favorite ones I'm going to show you is Penguin Watch. This is kind of like Snapshot Serengeti, where what happens is first you get some training, and then you get to look at these pictures. And let me see if I can, usually the picture's a bit bigger. But basically you see a picture, again, now we've got game cameras set up in Antarctica. And you look at the picture, and in this case I don't think I see any penguins. So I say, nope, I don't see any penguins, and I move on. And if I want to talk about the image, I can. I'm going to say no. Here's another situation. I don't see any penguins in that one. Nope. And I say, okay. And I don't want to talk about this image. And I say no. And I'm not going to make you suffer through this for a lot longer, but I'm going to do a couple more because these are just giving me, there we go. It tends to give you just random pictures, and my experience in playing on this before is that it doesn't take very long before you get to a picture like this with dozens or hundreds of penguins. So once you have the penguins in the picture, you get to basically identify them by putting a little X in the center of each penguin. And so you can see little orange marks appearing on the screen where each penguin is hanging out. And I'm not going to do this. Once you get to 30 penguins, it lets you stop. I'm not going to finish this one. But you also can choose between, oh, did I see any chicks? So this is not a chick, but I'm just pretending. And this one's not a chick, right? It does, again, there's a training module on this that I'm skipping over. But basically, again, in this instance, if you really love, maybe you went on a cruise to Antarctica and you are interested in continuing to learn about the Antarctic environment, you could participate on something like this. And again, in this case, be helping scientists to quantify information about penguins that they're learning out of these pictures. This is a fun one, old weather. In this case, different than looking at pictures, what you do is you sign up to, oops, I thought I was logged in here, but let me log in really quick. In this one, what happens is you become a cadet, so there's a certain amount of role play involved. And what they're asking us to do is basically digitize the weather logs from old ships, mostly from the 1900s. So you're assigned a ship, and you get a ship's log, and once you're in the ship, you actually go through and make some observations, recording some information about the weather that they observed, if they saw any animals, when they took on fuel. And basically what you're doing is, again, helping to digitize information that is captured in writing from these old logbooks to enable scientists to more readily access the data. And you can imagine that in this kind of a situation, you get to choose the vessel. Is it going to respond here? I think I have to say okay. There we go. So you can pick a variety of different vessels. You can learn about the history of the vessel and where it was actually traveling. You can find out what it was carrying and look for sample transcriptions. So for the history buff, there's not just the benefit that you're giving the scientific community by transcribing, but there's a lot for you to learn here as well. A similar Galaxy Zoo is similar to the Serengeti or Penguin Watch, where we've got spacecraft out in the space collecting pictures of our galaxies, and you go through and identify galaxies. This is a really fun one for hockey fans. It's called Rink Watch, and in this particular instance, as a way of looking at how our climate is changing, this, you can imagine, was started by Canadians. And what they asked people to do was register their outdoor skating rinks and tell us when it's skatable and when it's not skatable, which is going to be based on the weather. So you can see here that the blue little skaters are on rinks that are currently skatable, and this is between September 17th and December 17th of 2014. I can turn it on to see all the rinks, and you can see that these are all the people who have registered a rink, or all the rinks that have been registered. And so they change color depending on when people are registering information. And this just seems like fun, and it is fun, but it also provides some very interesting information. So if I look at these visual effects and I turn this cold map on, one of the things it does is isolate temperature profiles from around the country. And perhaps that just seems as though, well, you know, we have the Weather Service and they do these same sorts of things for us, and that's true. But when you think about the fact that this is engaging citizens to pay attention to their environment in a new way, that's maybe a different way and a more day-to-day way. If the kids are asking if they can go out and skate on the rink and you have to say, well, I'm sorry, again this year we can't even make the rink because the winter's not cold enough, then not only do we get interesting scientific information, but by the process of the observation, the participants in the project may start to look at an issue like climate change in a different way. I think that's all of the examples that I'm going to show you here. And at this point, let me stop again and see if there's any questions before I move on and talk about citizen science at St. Lawrence.
Okay, great. We'll see if anyone has their hand raised, or again, if you'd like to type in a question, you can do that as well. Okay, we might have a hand. Okay, it looks like Catherine Goodman has a comment or question. Catherine, go ahead.
I don't know if you can hear me, but I wanted to know if there's any website to go and find out other citizen science sites, like the old weather site and Project NOAA and that kind of
thing. Yeah, you know, Catherine, there's not just one good site, but there are a number of sites, and I would imagine that I linked a number of things in this PowerPoint, but I don't think you'll be able to access those links. But I expect if I work with Kim that I could actually post something. We could do a follow-up posting that has a number of links for finding some different citizen science projects. The citizen science is still fairly new, and in fact the first professional association about citizen science is having its first meeting this February. So there's not quite the centralized resource that you might hope for. But I do have a number of resources I could put you in touch with, and I'd be happy to do that.
Great. We have a typed-in comment here from Sue North. Hi, Sue. It says, just wanted to let you know that I lied. I have actually participated in citizen science, but I didn't know it. I count loons in Maine one Saturday morning every summer.
That's excellent. So thank you for the comment. And as I was hoping, hopefully many of you will find, oh, well, now that I have a better sense of what citizen science is, I know if I've participated. Counting loons is a great way to do citizen science, and that's a great example of the kind of hands-on citizen science. So this doesn't all have to be from your computer. Those are the easy ones for me to show you since I'm giving a webinar. But there's many instances. The birders seem particularly good, again, maybe because of the history with the Lab of Ornithology and the Audubon Society at organizing folks. So I'm not too surprised that it's a loon project you've participated on.
We have a typed-in question from John Feist. John says, without the controls that we expect in traditional science, is there a risk of skewed results based on who is participating and where they are?
That's a great question, and the answer is yes, there is a risk of skewed results. And so you have to design these projects carefully. I'm going to give an example in a minute of a project that we're doing at St. Lawrence that requires basically no training, where we don't worry about that very much. But you're absolutely right. For example, in the Snapshot Serengeti project, one way they get around that is by having thousands of people view each picture so they can start getting a sense of what confidence they have in the identifications that were being done. There are other citizen science projects that require much more training to participate in. So when I said there's something for everyone, there really is. I'm thinking of a couple of examples. One involves monitoring amphibians as they emerge and start breeding every year, where the way you monitor them is by recognizing their breeding calls. And in this particular project that I'm thinking of, you actually have to take and pass an online test at identifying the different species, where it randomly throws up different examples of calls, and they get progressively harder, so they throw in background noise, or maybe there's 3 species calling at once. And until you can pass that test, you're not allowed to contribute data to the project. So there are a number of different ways. Of course, the harder the project is or the more training it requires, the fewer people you're going to have participating, simply by virtue of the fact that you'll have some attrition. But it's a great question, and it's something people have to be thinking about.
I think that's it for the questions right now.
Great. So this is perhaps the part of the talk I'm the most excited about, which is to tell you about some of the initiatives that I've been involved with at St. Lawrence. And I'm going to give a shout out to one of the project, or one of our listeners tonight, who is Erin Siracusa. Hi, Erin, who was our first project manager for the Nature Up North project. Nature Up North is not just a citizen science project, but it's where we're doing citizen science in St. Lawrence. And so let me tell you a little bit about it. A couple of years ago, a number of colleagues and I got together and responded to what we've been seeing pretty regularly in St. Lawrence students and local kids and local community members. And that was a loss of knowledge about the natural world in which we live. And I'm going to give you some more examples of that in a minute. And at the same time as that knowledge was being lost, we also noticed more and more people on their smartphone or playing video games or connected to technology rather than connecting to the natural world. And so we established the Nature Up North project in an effort to address that. But rather than go the old school way of saying, well, throw down your technology, we're not going to use that, everybody go outside, we decided we would try to leverage people's interest in technology coupled with hands-on and place-based learning to try to help build up people's connections to and appreciation for the natural world. So there's three primary goals of the project. The first is to get North Country folks outside, reconnecting with their natural environment, and in hope that in so doing we'll build an environmental community. And part of that building of community happens on our website, and I'm going to show you the website in a couple minutes and give you an example of that. With the final ultimate goal of improving bioregional literacy, and I'll give you another example of this in a minute, but by bioregional literacy I mean understanding and awareness about the place that you live, and not just about the natural features that are there or the recreation opportunities or the underlying geology or what species of plant to put in your garden at what time of year, but also how the natural resources in your area interact with the economic opportunities in your area. So for instance, here in the North Country, we've got lots of forests and there's a lot of people who log. We've got lots of maple trees and there's lots of people who produce maple syrup. Wherever you live, there's going to be different ways in which the natural resources around you impact your economies and your communities, because whole culture emerges from the kind of place that you live. So up here, we're just finishing deer season, and there's lots and lots of North Country residents who, by virtue of where we live, are deer hunters. And so that's just an example of how the culture is partially informed by the place that you live. There's three major components to the project. The first is the website, which we think of as a virtual nature center, and I'll show you the website in a moment. But St. Lawrence County in particular, and the North Country in general, is a huge geographic area with a really low population density, and we lack any sort of bricks and mortar nature center. And you could imagine that if you build a nature center, and those of you who have been in the area recently will be aware that in Tupper Lake there's the Wild Center, which is a nature center and sort of environmental museum of the Adirondacks. But even still, for somebody who's a low-income person who lives up by the St. Lawrence River, that's not really a resource that's easily available to those folks. So we're using the website to create kind of a virtual nature center. We couple that virtual experience with experiential workshops and programming, and you can see that by the people pictured in the canoes. They were participating in a goose roundup for the local Department of Environmental Conservation. And then the third prong are some citizen science projects that we've slowly been unveiling. So let me tell you a little bit more about each of these things. Basically, as I said, there's the website, citizen science projects, and experiential learning, and the three serve one another, so that for the website content is generated by St. Lawrence and other college students and faculty. And here I'm talking about the informational content on the website. We write articles about, for instance, where can you buy a local Christmas tree, or what's the history of turkeys at Thanksgiving, or we recently posted a video about turkey hunting that was produced by a North Country resident. We also have a number of elementary, middle school, and high school students posting content to this site. And slowly we're putting together a number of different kinds of resources. In addition to the articles, we've got a bunch of trail maps that we've digitized and posted, and you'll see in a minute some of the other features of the website. The citizen science data, the web serves as the portal for collecting all of the data, and the data can be collected from students at any level or community members. And then the project and the experiential learning components are facilitated by Nature Up North staff and interns. So currently the staff are me as project director and Jake Malcolm as the project manager, and then we sort of work with a whole bunch of people at St. Lawrence. This is a St. Lawrence University project, and so our primary source of funding comes from the university. And one of the things that Jake and I do during our winters is write grants to get additional funding for the project. I've been teaching a class with Mary Hussman in the English department that's an environmental education class, and we are training students to serve as interns for the project. For instance, last weekend they did a number of public outreach projects. One was a winter bird feeder making activity, one was a geocaching lesson, and the third was about habitats for kids. So those were free and open to the public. We also work with teachers and other organizations to team up and participate together on getting people into the out-of-doors. Again, the funding comes primarily from St. Lawrence and grant money that we're able to acquire. So how Nature Up North does citizen science is really in three, I guess I'm going to give you three examples tonight. And this first example is what I'm calling Citizen Science 101. And it's one of the basic elements of the Nature Up North website, and it's called an encounter. And basically the idea is that any person who sees something cool in the North Country can share it. And they post an observation, and captured with that observation are some data on the date and the time and the location. So each of the pictures that you see before you are examples of observations that were submitted by North Country residents. I'm going to take you to this albino deer as an example. So this is taking us now to the Nature Up North website, and this is the encounter that was put together by, in this case, Maya. She's actually a person I met. She lives in Potsdam, and I've met her through her participation in Nature Up North. So it's kind of neat for building community. So in this particular instance, Maya saw this albino deer, and I, as an interested party, can say, hey, I think this is cool, so I can mark her deer picture as Northworthy. I can share this to Facebook if I want. I'm not going to do it right now, but I can say, hey, I saw this cool thing on the Nature Up North website. I'm going to share it to Facebook. It captures the location where the picture was taken. In this particular instance, Maya has explained in the narrative that she has adjusted the location a little bit. So it's approximate to where the deer was, but the local neighbors were worried. They'd been seeing this deer for 7 years, and they were worried that if she put the actual location, he would be shot. So even still, from the scientific standpoint, we now have captured a piece of data that tells us there's an albino deer running around in this area. And as a biologist, I know it doesn't matter whether it's here or over here or over here. That deer is probably using all of that space, right? If we scroll down a little bit more, we can see the picture. We can see, hey, there's the strange lady with the porcupine made a comment. We've tried to push for some interactivity here to build that sense of community. The website will tell you, oh, here's some similar encounters by the same explorer. In the Nature Up North website, you're an explorer if you participate with us. And then there might be similar encounters with some indications about how many different people voted them Northworthy. If we look at the main website, if you look at this on your own at home, you won't see these big black and gray bars up here at the top. That's because I'm one of the site administrators. So it would look a little bit different for you. But basically, when you come to the main website page, the main page, this first map, each of these pins is an encounter that someone has posted. And so if I look in this case and say, oh, here's a posting of a Lake Champlain landscape, and if I click on this, it will again take me to that person's encounter and give me the opportunity to see the picture and post any comments that I might want to have. So at the reason I call this Citizen Science 101 is because the people who are participating in this level of the project are not actually probably thinking of themselves as scientists or people who are collecting data. But the fact that we're recording all of these data in one location that isn't something like Facebook, where the pictures are not actually being collected and curated, and where we have associated with each encounter a date and a location, we're able to start building a good sense of our area. And so, for example, I hate to imagine this. Those of you who can remember your time at St. Lawrence perhaps remember swimming in the Grass River. And the Grass River is still very swimmable, and students swim there regularly, as do community members. But let's just imagine for a moment that in 100 years the river is polluted and you can't swim there. The data that we're collecting right now are helping to capture how people interact with the environment right now and over time. And so as we collect data into the future, we start putting together a picture of not only what species are here at what time of year, but how people and how our culture develops around the natural resources that we live with. So again, from the standpoint of citizen science, this is citizen science light, and the data are, we're not trying to push this as, hey, you're being a scientist. We're spinning this as, hey, share your experiences in the North Country. A couple other things I'll just show you. If I come up here to explore the North Country, we've got an event calendar that helps people figure out when we're doing our hands-on activities. You can look at all of the encounters rather than the map version. Here's our trail guide that we're just building out. I think it went. Oh yeah, there it goes. So in this case, what we see are, oopsie, I guess I'm a little exuberant with the mouse there. But you can see if I click on a pin, it will tell me, oops, except I'm having trouble with my mouse. Let's try that again. Here's the hike to Mount Arab. You get a little description. If you click on that, it will take you basically down the page to the Mount Arab information, which gives us, if I scroll down here, a printable PDF map that you can then take to the location where you're hiking. These maps were all built by a SUNY Potsdam student who had an internship, and she came and worked for us for free. SUNY Potsdam paid for her internship. She had experience in geographic information systems and wanted to do something like with that. And so she built these maps for us where the front, they're all standardized, they've got the trail, and then the back side of the map has a description of what the hike would be like. So this is what I mean by using Nature Up North as basically a virtual nature center. Not only is there information about the encounters, but we've also got maps. And the next piece that we're building out are some descriptions of different species. If we go back to the home page, you will also see, it's a little bit slow tonight, but you'll also see if we scroll down here, the articles, and so I can click on one of these. This was written by one of our summer interns, and it tells us about the day in the life of an arborist. So again, we have the opportunity to share information that's local about our community with people. So that's the website, and that's the example of Nature Up North's most basic instance of citizen science. Our more scientific approach revolves around the idea of phenology, which is what we think of as the timing of seasonal biological events. So for instance, in the upper picture on the left, that blob of goo is a group of frogs' eggs, or actually in this case I think they're toad eggs. And you could wonder, you know, when do the frogs start breeding? Or when do the maple leaves turn orange and yellow and their brilliant colors and fall off the tree? Red-winged blackbirds are migratory birds in the North Country. When do they return every year for their migration? Even something as simple as when do the crocuses in your yard open? Tracking these things helps us understand how our climate is changing, and it helps us understand it at a local level. We're going to take about 2 minutes and watch this little video that explains phenology with a few more examples, and then I'll move back to talking. This is from a TED Talk, so we get the little TED intro here.
Take a look outside a window. What is the season where you are? How do you know? Most likely, you looked at a tree or plant and noticed details about its leaves and assessed the qualities of sunlight streaming outside. Observing the timing of biological events in relation to changes in season and climate is called phenology. When you notice the daffodil buds are poking through the snow and think spring is on its way, you're using phenology. When you see leaves turn from green to red and watch migrating birds fly past and realize that summer is over, autumn is here, you're using phenology. Literally meaning the science of appearance, phenology comes from the Greek words pheno, to show or appear, and logos, to study. Humans have relied on phenology since the time of hunters and gatherers. We've watched changes in seasons to know when to plant and harvest food, and when to track migrating animals. Scientists observe and document seasonal changes in nature and look for patterns in the timing of seasonal events. Timing of these natural signs has remained consistent until recently. Increasing global temperature is causing rhythms of nature to shift. Budburst, the day when a tree or plant's leaf or flower buds open, is occurring earlier in the year for some species. For every 1 degree Celsius rise in temperature, budburst happens 5 days earlier than usual. Differences in timing affect not only plants, but the insects and birds that depend on the plants for food. For example, oak trees in the Arnhem forest of the Netherlands now experience budburst 10 days earlier as compared to 20 years ago. New oak leaves are a favorite food of winter moth caterpillars. To survive, the caterpillars adapted to the change in the tree's timing and now hatch 15 days earlier than before. Migrating pied flycatcher birds, however, aren't doing as well. The birds prefer to feed their chicks winter moth caterpillars. The caterpillars are now hatching earlier, but the birds' chicks are not. This delay is costing the birds a food source. The pied flycatcher population has decreased by up to 90% in some areas as a result. Changes to a seemingly simple event, leaves opening, has ripple effects throughout a food web. Earlier bloom times can also have an economic impact. The famed cherry blossoms in Washington, D.C. are blooming 5 days earlier than before. Since the cherry trees are blooming earlier, the blossoms also fade earlier, frustrating thousands of tourists who visit for the Cherry Blossom Festival. High school marching bands plan all year to attend the parade and perform surrounded by a majestic white canopy. How disappointing for them to find, well, trees, rather than the famous cherry blossoms. Plants and animals react to changes in natural light and temperature. Increasing temperatures cause plants to bloom earlier than before and become out of sync with the insects and birds in the food web. So the next time you look out your window and notice what season it is, you may be fooled by those blooming trees. Think of phenology, then think of how you can play a part to slow climate change.
So I hope you enjoyed that cute little video with some information about the idea behind why studying phenology is useful if you want to look at how our climate is changing and what the impacts of the changing climate may be on the ecosystems in which we live. Another aspect of phenology that I think is really helpful in a citizen science context is that it's something we're used to paying attention to. It's something, you know, especially those of us who live up here in the North Country are absolutely ecstatic when we see the first sign of life in the spring after a hard, cold winter. And so it's the kind of thing you notice and you talk about and you pay attention to. And when you take a subject like climate change that through our political system has become really polarized and we've moved away from thinking about it necessarily from a scientific standpoint and more think about it from an ideological standpoint, it might be easier to engage people in conversation not about ideology but about the observations that they're making in the places where they live. So rather than confront people in an aggressive way about what they may or may not believe about our world, using phenology, you can ask people just to start paying attention and making observations and hopefully doing what scientists do, which is letting the data speak for themselves and let people come to their own conclusions about how they think the world is operating. So here at Nature Up North, we have introduced a project that we call Monitor My Maple. Maples are a really obvious and dominant species in our area, and the way it works is participants choose a sugar maple that they see frequently. It could be their yard, it could be here on campus, it could be in the woodlot out behind their house. They measure and record the circumference of the tree using a very sophisticated piece of equipment called string, so it doesn't require any fancy technology. And then they keep an eye on their tree, and they pay attention to it in the spring and during the fall and record the dates when the bud break happens in the spring, and they just talked about bud break in the video, when the leaves come out in the spring, and also the timing of color change and leaf drop in the fall, and they enter the dates on the Nature Up North website. So we'll go look at this fall's Monitor My Maple site. And so what you're going to see is what a participant would encounter. So in this case, it's looking at one of my old entries. But basically, as the participant comes to the page, they walk down the page, and there's some instructions with some pictures to help you see and understand what species of tree you're looking at based on leaf morphology. So you tell us what species. You can put a picture of your tree here if you want. You provide the location of your tree and answer a number of questions about where your tree is located that help us to understand, is it going to be in a park? Is it close to the road? I have a beautiful, huge maple tree in my front yard that gets salt and sand and all sorts of things on it every year. I think it was probably planted in about 1840, so I try to baby it along. And then there's also some questions about some information about how to measure your tree, where you can record the circumference, and also some information about how to record any damage or disease that you might see on your tree. And what we've done is we've adapted in the data that we collect from some nationwide phenology projects so that the data we're collecting are compatible with data on a nationwide scale. So that not only do we learn more about the North Country maple trees, but we also can share our data on a national scale with some other projects. So once you've entered all of this information, you hit submit. The average user doesn't see this next part because they're not site admins, but if I just look quickly at the results here, this is some of the participants. So that we had 472 participants this year. We engaged with a number of schools, mostly 5th and 6th graders in a number of school districts around the area. So for instance, Stephanie Playstead is a 5th grade teacher in Gouverneur, and all of these entries under her name are different students in her class. So we went with our interns to the school, and we took the kids outside and we trained them on how to monitor their maple. And it was really neat because the kids were doing things like taking selfies with their maple and hugging their tree and naming their tree and really engaging in a very human way, but also talking about how we collect data as scientists and what the data might mean for us on a larger scale. So this has been a really fun project for us to participate in. And you might say, well, why maples? There's many different things you could look at. But again, we're trying to make the connection between science and place. And because sugar maple is a dominant tree in the North Country, there's over 200 maple producers in St. Lawrence County alone. It's about a $2 million industry. We produce in the North Country about 1/3 of the state syrup production. And if you look around the county, over half of our forests are dominated by sugar maple. And if we look at how much of that maple we're actually utilizing, this figure is looking at potential taps in our region of the state. And so you see on the y-axis is looking at the potential number of taps. And in St. Lawrence County, we're at over 25 million untapped trees. And then the colors on each bar tell us about where those trees are located on private land or reserve land or state land. So you can see private land in St. Lawrence County is full of untapped potential for maple production. And at the same time, climate change rears its ugly head. And so in this particular picture, the left-hand map is showing us the current distribution of different forest types in the Northeast. And the maple beech birch color is basically the kind of mustard yellow color with some spruce fir forests, mostly in Maine. And so that's the current distribution of maple forests. The middle map is showing us a low emissions scenario. And these are data that come from a paper from 2010. So the maps are models of how the forest type might change under different climate change scenarios. And so you can see in the middle picture that oak hickory, which is a more southern forest type, is expanding its range north through most of Pennsylvania and encroaching into New York, and we lose the spruce fir forests entirely. It turns out that we've already passed the lower emissions scenario, so that's unlikely to be the pattern that we would see in New York. Notice under the higher emissions scenario that we've got encroachment of oak hickory through most of the state. We only see beech maple forest in the high peaks and the central Adirondacks and basically northern Maine. And we're also talking about the potential loss of the maple industry in Vermont and New Hampshire and Maine as well. So one of the reasons to pay attention to maples is to start understanding whether or not they are being impacted by climate. Of course, we try to choose a project that seems of value to the community, and some of the benefits are that participants develop familiarity with important local species. And I don't know if you know how to recognize a sugar maple, but I am astonished at the number of students I meet in my intro biology class who can tell me and recognize the picture of every pop star known to humanity, but can't identify the 3 trees that they most commonly encounter and have encountered on their walk to school for the last 20 years of their life. It also encourages participants to think critically about seasonal change and how it relates to climate change. And even just by practicing the skills of scientists with string and a ruler, measuring and recording data, helps people understand the process of doing science, which should improve scientific literacy. And finally, out of all of this, we hopefully get an improved understanding of an important local resource. Another citizen science project that we're launching is based on a program called Monitor Change, which is developed by biologists at the USGS. And they made a pretty cool observation based out of the idea of citizen science, which is you could crowdsource time-lapse videos. And basically their thought was, if you could have a fixed photo point somewhere so that every time somebody came past that photo point, they took a picture and submitted it to you, you would be able to build a sense of how that space was changing without having to stand there yourself or put a camera there yourself. And so this next video is a pretty quick one. It's just giving you an idea of the potential of this. And this is the professional-made video. in that particular video, that's an artist who has taken a fixed camera outside of his house and had it record a picture every day at the same spot. What drives me crazy about it is it's never night for that whole year that we watch the video. But you can kind of see the potential for looking at change and really thinking about seasonality. And so we got the idea that perhaps we could engage in the local schools having kids do something similar. So what I'm going to show you is a never-before-seen video. Even the kids who have been participating in this haven't made it. And I will warn you in advance that it does not have the technical luster of the previous instance. This first one is some pictures shot. We just rolled this out about 2 weeks ago in the local schools. And so these are some pictures shot in East Side Elementary in Gouverneur. Get ready. If you blink, you'll miss it. Right? So not a whole lot happening there yet. Play it one more time, if you will, Kim. But basically what we've done here that's a little different than in the video you just watched is we went out to the school. We worked with the kids to choose a spot that might be an interesting place to observe from, and we set up a fixed observation post. And what the kids do is they take turns, and they're really excited to get to be the one whose day it is. These are 5th graders. They take an iPad out to the fixed photo location. They take a picture, and they submit it to us on the Nature Up North website. And then we can download the pictures, and basically because they're taken at a fixed point, we can photo correct them and string them together into these time-lapse photographs. Our participants at Canton Central School, the teacher who we're working with there teaches several more classes during the day, and so we're getting a lot more pictures from them. And this next video will be from Canton. Again, never before seen, the premiere. So except for the fact that I am not a good video editor and there's we have some technical side effects we need to work out, we're actually really excited in that not only are we doing something that has the kids outside every day making some observations about nature, but it's also engaging them in a way that's meaningful to them, which is in using technology. We think that the technology for actually stitching the pictures together is something that 5th and 6th graders can learn, and we're just now starting to build a method for doing that. So they build their technology skills and their science skills and their observation skills, and they get to go outside. And then we're coupling this. These are the same kids who are participating in the Monitor My Maple project. So we're coupling it with thinking about phenology and seasonal change and a changing climate. It's something that we started developing in our environmental education class, and in fact we're working on setting up a photo point here on campus. You are perhaps aware that last year the chapel burned, and so what you see there in the front and center of the picture, this picture was shot in, I think, mid-November, and you can see that the steeple on the chapel is gone. You're taking a look across the newly reconfigured quad from the newly named Kirk Douglas Residence Hall. And so one of the things, if you haven't been to campus recently, is that this has really revived this side of campus, having a residence hall here. And so we're going to set up one of these photo points here at the beginning of next semester, and again crowdsource. The nice thing in this instance is we've got the trees and the grass, and so right now, if you were on campus, you'd see we have snow and rain, so it looks a bit different than this view. So we'll be able to capture the environmental change, but also change in a really culturally significant landmark on campus. And so we're really interested in this kind of crowdsourcing of information as a way to record change and help people think about this kind of thing. So those are some of the things we're up to. Why this matters, I'm starting to wind down here, and so I'm going to go quickly through these. But part of our philosophy is people need to reconnect to nature, and there's actually a disorder that has been described by a guy named Richard Louv, who wrote this book, Last Child in the Woods. A number of symptoms emerge when people don't spend any time connected to nature. Go ahead, Kim. And so the statistics are really sobering. The girl on the left is, of course, playing a video game indoors in the dark, and that's how young people are spending their time, 7 hours a day on average, 50% less time outside than even 10 years ago. And what that means is people lose bioregional literacy. So we're going to take a little quiz here. It's always good to have the quiz at the end. And I recognize that you're not all in St. Lawrence County. Most of you are not. So you could imagine modifying these questions to where you are. But as long as you're in the northern hemisphere, the first question should be correct. So think to yourself for a moment, do you know when the next full moon is? This is not a poll, so just think if you have the answer, and then we'll give you the answer. Okay. So if you said January 5th, you would be correct. The next question, can you name 2 spring wildflowers that are among the first to bloom in your area? Here in Canton, they might be, Claytonia virginica, and I'm forgetting the common name, but that's the plant on the left, and the dogtooth violet on the right. Those are 2 of our earliest, spring beauty, that's the common name for the plant on the left. 2 of our early wildflowers. Or could you identify who makes this sound? And if you guessed it was a bullfrog, you would be right. But bioregional literacy has to do not just with the natural phenomena, but also the human aspects of where you live. So for where you live, do you know the approximate population size of the city or county in which you live? Here in St. Lawrence, it's about 111,000 people. Could you point north from where you're sitting? Do you have a sense of kind of where you are on the globe? And do you know what percent of the residents in your area live below the poverty level? Here in St. Lawrence County, it's about 18.5%. All of these things together we call bioregional literacy. And one of the goals of the kind of citizen science we're doing at Nature Up North is to help reinstill people's sense of bioregional literacy. So with that, I'm going to encourage you to get outside, observe, record, learn, share, grow. These are all some of the things we can do together through participating in a variety of different citizen science experiences. And with that, I thank you, and we'll stop and say if you have any other questions or comments, we'd welcome them at this time.
Okay, wonderful. We'll take a look back through the list of attendees. Again, raise your hand or type in a question or comment if you have one. Okay, we've just got a comment from Sue North saying, thank you so much. It was a great presentation and a great initiative.
Thanks, Sue, for joining us.
And it looks like we may have a hand up as well. Karen Heath. Karen, go ahead if you have a question or comment.
So I just wanted to thank you. This was fascinating. I didn't know a thing about what citizen science was, but it is all around me, and I work in elementary schools, and I love your connections with the students around.
Oh, great. Thanks, Karen. We're really having fun, and what's been amazing is the teacher feedback. One of the things the teachers have really appreciated is actually we work on, I don't know, Karen, where you are, but we work with them to help do Common Core stuff in a way that's locally focused. So for instance, our 5th grade curriculum here has students learning about the rainforest, and yet in most of our schools, they have a forest right near the school, but they don't go out and learn about their own forest.
Right. So yeah, that's great. I'm in Vermont, so not very far.
Vermont. Yeah.
Barry, Vermont, and
yeah,
I just taught a science and literacy course, so I'm really interested in this, and I'm the Common Core implementer for our school, or one of them.
Okay.
So I think it's great when things have a real life. So
yeah, it makes such a huge difference, doesn't it? Well, thank you, Karen, for your feedback.
Well, thank you.
Just checking to see if we have any other questions or comments. It looks like we have another one. Okay, we've got a comment here, a question from Stacy Smith. Stacy says, as a middle school science teacher, I have gathered many new ideas for my students to become citizen scientists.
That's great. I'm really glad to hear that. Let me know how it goes.
Looks like we may have another hand raised here, so we'll just go back through the list. Okay, any other questions or comments? We'll give it just a minute more. Type in your last minute thoughts or questions.
As you're thinking about that, I'll just say that I will work with Kim to get some resources about different citizen science initiatives so that we can get those out to you.
Okay, it looks like we're good. No other questions or comments.
Terrific. Well, thank you all for participating.
Great. Thank you to Erica for leading our lecture tonight, and thanks to all of you for participating. As soon as the lecture is over, you'll receive a link to complete a very brief online survey to let us know what you thought of the lecture tonight, and also gives you the opportunity to share any ideas that you have for future lecture topics or presenters. So we look forward to your feedback and hope you'll join us for future lectures in the spring semester. So have a great night, and thanks again.
Thank you very much.